welcome everyone to day 3. We are halfway through our program right now, so I'm really excited. I hope all of you are too. We've definitely covered a lot of content throughout this, and today we're going to be covering pandas, which in my experience is really important. I found myself using it in research that I've done and also in an internship I've worked in, so this is definitely going to be a useful skill. Apart from that, as a reminder, we have our website, which was launched 2 days ago, techgirlsunited.wixsite.com/tech, so make sure to check that out. Along with that, I'm doing a story takeover on Instagram today, and I'll be talking about Tech Girls United and another organization I'm a part of. So if you guys want to check that out, you totally can. We've also reposted it on our story on Instagram, so definitely check that out and ask me any questions you have over there. I'll be answering those over the course of today. Other than that, I don't have anything else. We'll be going over the final project a bit more today, and hopefully the lesson on pandas today will help you a lot more with visualizing the data you're going to be working with. If you have any questions about the project as well, make sure to ask at the end after we've gone through the entire pandas curriculum. And as always, make sure that you're asking questions in the chat as you have them, and then I know Shalini will keep checking the chat as she needs to throughout the lesson. So, yeah, that's all I have. Shalini, do you want to start screen sharing?
Yeah, for sure. Cool. Can everyone see my screen?
Yep, we can see it.
Cool. So I hope everyone is doing well, staying safe. So like Megan said, we are going to be talking about pandas today. So pandas, it's not like the animal pandas. This is a Python library that is super useful, and I think it's a way to like visualize your data a lot better, and it's like super powerful, and we'll get a little bit into that today. So going into what Pandas is, so it's this really super useful Python package. So yesterday, Trisha talked about NumPy. So this is a different package to NumPy, but each of these are different packages, and you can use it along with Python in order to code out different things, do different things with your data. So specifically Pandas, we use it for kind of like tabular data. So anything that's shaped like a table, I like to think about it like that. So doing different things with tables, different operations, like rows and columns and stuff, that's what Pandas is really useful for. So there are two main data types in Pandas. So there's something called a series, which is one-dimensional, and there's a data frame, which is two-dimensional. And I'll be talking a lot more about this in a bit. But those are the two main data types. So when you hear pandas, you'll oftentimes hear series and data frames because of that. And just a little extra information, Pandas is built on top of NumPy, and you can use a lot of other libraries along with Pandas. So tomorrow, Trisha will be talking about another library called Matplotlib, and that is something you can use along with Pandas, and oftentimes are used together. So in order to start using Pandas in your code, you first have to import the package, and this allows Python to access all of the different functions and the different methods that are within the package. So similar to yesterday with NumPy, we use the same import statement. So we do import pandas as PD, and like with NumPy, we used NP. Pandas and PD oftentimes go together. That's a very common and very, what's the word? It's just like used a lot in industry, so people recognize PD as pandas. Yeah, so there's a lot of different things you can do with pandas. I just listed out a few things here, but um, essentially, like, you import your data, you have this table of data. You can insert data, you can delete columns of data. If there's missing values in your data, you can handle that in a very easy way. You can add data together, transform your data, so you can actually like change the values of your data. If you have like multiple different data sets that you want to work with, you can do that in pandas. And yeah, there's so much you can do with pandas. If you're interested, you should definitely check out the documentation for pandas online. The documentation basically lists out all the different functions that you can do with pandas and like how you would code it out. And it explains what it does and gives you examples. So it's super useful. So in order to kind of use these functions in pandas, we do this notation at the bottom. So we use PD because that's how we imported pandas. And then we do dot and then the function name. And this essentially tells Python that, okay, we want to use the pandas library, and then we want to use this function which is within the pandas library. So talking about data frames, so this is one of the main structures of pandas. A data frame is essentially a table. It's just, I guess, a fancy way of saying it. It looks exactly like a table. It has rows, columns, it has column names, and it like labeled rows, as you can see from this very simple data frame. And it's 2D because it has a row and a column. So there are different ways that you can have a data frame in pandas. So to make a data frame, you could create your own data frame. So this line of code over here is just an example of how I made this data frame that you see of Jack and Jill and their ages, which is completely made up, by the way. But so you would do pd.dataframe, and this is a function in order to create a data frame. Then you input your data. So we kind of see this bracket structure with lists. So we see Jack, 13, and this corresponds to the first column, this one to the second, and then you use that same bracket for Jill. So the comma separates each row. And then you have to label the column name, so whatever you want to call it. So in this case, I labeled it name and age. So this is one way how to make a data frame. Another very common way to kind of get a data frame into pandas is to import it. So a lot of times you'll have data that you've created from somewhere else, or maybe someone else has created it for you, and maybe like you've seen like CSV files or Excel files. So another way to import kind of this type of data, so you can import it using different functions. So here I have pd.read_CSV, and this is a great way to read in a CSV file into pandas. And this really allows us to analyze almost like whatever CSV file or data that we want within pandas. So this is a very super useful function. I use it a lot. But yeah, any questions so far? Cool. Also, just like a very general note, but I just for it to be like easier with like REPL and all, I'll be going through the slides first and then going to the REPL and showing you everything, just so like REPL hopefully doesn't like crash on me because I keep switching slides over and over, or keep switching windows. But yeah, so let's move on. So the other type of data structure that we have in Pandas is a series. So this is 1D. So if you think about the table that we had with Jack and Jill before and the name and the ages, if you take one column of that table, that's essentially kind of the structure of a series. You can imagine it as like one column of a table. So since it's like a portion of a data frame, it's like 1D. So in order to make a series, you can use this function, so pd.series, and then you can input your data. So here we have like one column, you can say. So we have Jack and Jill, so this is kind of like that name column. So it's 1D, as we see here, one column. So looking at different parts of a data frame, so oftentimes when I import a certain CSV file, some data, I have my data frame. I want to kind of check it out, see if I imported the right data, see what's going on with the data, what it looks like. So some really useful functions in order to do that are the head and tail functions. So the head function gets the first few rows of the data frame, and the tail function gets the last few rows of the data frame. And this is super helpful if you just like want to kind of get a sneak preview of what your data looks like before you start playing around with it. You can look at that. And especially if your data frame happens to be super big with tons and tons of rows, you don't want to be looking at the whole data frame all at once, because that's going to slow down your computer, that's going to slow down everything. So looking at head or tail helps you to just kind of speed that process up. That way it doesn't slow everything down. So typically, if you just were to type this in, so you have your data frame dot head and then parentheses with nothing in it, this is going to just output 5 rows. So that's the default for both of these functions. So this would output the first 5 rows, and then tail would output the last 5 rows of your data frame. But you can specify how many rows you want. Let's say that you want to see, I don't know, the first 8 rows. You can do df.head, and then in parentheses, you can do 8. And then that would output the first 8 rows. So that's very flexible and really nice. So another thing that's also super useful, just kind of like once you've imported your data and created your data, is checking out the shape of your data. Oftentimes you might be importing a data set and you have no idea what's in it. So all of these functions are kind of to get a sense of like what your data looks like. Maybe you've changed something and you want to see what it looks like as well. So this df.shape tells you how many rows and how many columns you have. And it does this in the form of a tuple, which is a data type that we talked about on Monday, if you remember. So in these parentheses, the first value here represents how many rows we have, and then the second value here represents how many columns we have. So this shape, this tuple, represents this data frame over here, this Jack and Jill data frame. So we have 2 rows, 0 and 1, as you can see here, with Jack and Jill, and then we have 2 columns, the name and the age columns. So that's df.shape, that's the shape function. It'll always tell you like how many rows and columns. A slightly different function is the size function. So this tells you how many actual like data entries there are in your data frame. So in this example, we have 4 because we have Jack, 13, Jill, 15. So 4 different entries. So this value is actually the number of rows times the number of columns. But both of these are really nice just to get a sense of what your data looks like, how many different data values you're working with. Maybe you have tons of columns, then this value would be huge, or if you have a lot of rows, it just kind of gives you a sense of what your data looks like. So some other cool functions. So looking at columns and values. So in order to get the columns that are in your data frame, you can use df.columns, and it will return this nice list structure with what each of the columns are. In a lot of data sets I've worked with, there have been tons of columns, like more than the 2 that we see here. And a lot of times it's just a lot easier to see, like, okay, what type of columns are we working with before getting started. So this is a very simple and useful function that you can do for that. And then kind of on a similar thing, since we can get the columns, we can also get the values themselves. So that you can do with df.values. And yeah, it returns this array of all the different values. So it's formatted as lists. And this can be helpful too, based on the situation. But yeah, you can get the columns and the values using both of these different functions. So a few other cool operations that are used pretty commonly based on what you're doing. So you have a table, you have your data frame, you can sort the different rows of a data frame based on your columns. So to do this, we use the sort values function. So you can input whatever column you want to sort by. So let's say that we have our same Jack and Jill data frame, and we want to organize it by the age. So we want the entries with the youngest age to be at the top, and then the oldest age to be at the bottom. So order it from in like ascending order. Then we can use the sort values, and then in here we would put the column that we want to sort by. So in this case we would put age in here, and then ascending true because we want it to go from youngest to oldest, from top to bottom. And let's say if we wanted to do descending, then we would do ascending equals false. So this is this ascending word that you see here, this is a type of parameter for this sort values function. And by putting true or false, that determines like what order that we're going to sort everything in. And then we also see this in place parameter. So this, so let's say that we sorted something and we want to use that new sorted data frame for something else afterwards. So we can choose to either do the operation in place, meaning that it will just adjust this df data frame, or we can choose to set it to a new value. So we can like make a new like sorted data frame and then set it equal to this sort values. And I'll demonstrate this in a little bit when I get to the code part of this lecture. So another cool thing that you can do, you can change the names of your columns. So let's say that you maybe want to make something more specific or want to change the name, whatever it is, you can use the rename function. So all you would do is use the rename function, then whatever column that you want to change, you would put the original name of the column and then the new name that you want to do. So going back to our Jack and Jill data frame example, we have our original data frame, which has name and age as the columns. Then after doing this, the data frame becomes, it has first name and age as the columns instead. So we didn't change any of the data. All we did was change the name or change the value of this one column. So so kind of some more details about columns. So each column of a data frame has a certain data type. And we talked a little bit about data types on Monday, but just to reiterate data types and knowing what data type something is really important and helpful, because based on the data type of something, that determines what type of operations and functions you can use with that. So in Pandas, each of the columns that you have will be a certain data type. And in order to see what that data type is, we can use D types, which stands for data types. And we can use this function, and the output would be something like this. So we have name, which is an object. Pandas doesn't really differentiate it, like it's a string object, so it just calls it an object because name is a string. And then we have age, which is an integer because it's a numerical value. And then there's also a way you can change a column type as well. So in order to do that, you would just use the as type function, the column that you want to change the data type of, and then what you want the data type in order to be. So let's say that we wanted to make this age, instead of an integer, we want to make it like into a string, for example. We don't want the values as integers, we want them as strings. So then we can do df.asType, have age, and then put string in here, or str as string. So this is one of my personal favorite functions in Pandas, just because I think just by doing this one thing, you can get a lot of insights on your data. And it's a really nice way to kind of see the values of your data kind of condensed down. So this is called value counts. And what it does is everything, so the data type it uses is a series. So you can only use this function on a specific column, for example. So you would take the series that you have, and let's say we have a series with a bunch of numbers in it, and then you can call .value counts, and then you can see each of these values. So we have, in this series, we have 1, 2, 3. You can see how many times it appears in the series. So kind of like how many times does each value occur. And I think that's super cool, and because it makes it a lot easier than like counting out each value. You can just run this one function in order to see what how many times each value appears. So now getting into indexing and slicing. So indexing and slicing is used if you want to select certain columns or rows from your data frame. So maybe we don't want to use our whole data frame, we only want to use a part of it. So this is a way in order to cut down your data frame, or select everything that you want to keep. So we can use this in multiple different ways. So we can, the first method I'll talk about is bracket notation. So we can, so let's say we have a data frame. Using the bracket notation, we can select certain columns from our data frame. So the format for this, you would have your data frame name, then open bracket, the column or columns that you want to select, and then close bracket. So I guess let's do an example. So if like going through this, so let's say we have our same Jack and Jill data frame, and we want to just select the name column of our data frame. So we can do df, and then here we see two brackets, so we have a list of name. So then the result is going to be a data frame, except it's like a one column data frame. And instead, on the other hand, if we look on the right side, here the difference is we don't have a list within the brackets. Here we just have the column name. Here this is going to result in a series. So based on if you want your result of what you're selecting to be a data frame or a series type, you would either put two sets of brackets where this one represents a list, or you would put one set of brackets. Also, any questions so far? I'm going through a lot. Just want to make sure that everyone's understanding. I also think a lot of this will make sense when I move to REPL, and I have a different data set that we'll be working with there too. Not just Jack and Jill the whole time. Okay, let me move on. So this bracket notation it only works for columns. So let's say that, so if you remember, we had the Jack and Jill data frame, and then the rows were labeled 0 and 1. If we tried selecting, let's say we want the first row, and we tried putting 0 in there, it wouldn't work because there aren't any columns that are named 0. So doing this bracket notation works for columns. So that is an important note. There are other ways you can select rows, though, which we will get into, but this specific way only works for columns. So there's kind of a nifty function that you can use called lock. I think it might stand for location. I'm not 100% sure, but locate or location, one of those. And it essentially, this is something that you can use to locate or select rows, and you can do columns, and you can do both of them at the same time. And you use the row and column names. So I guess this is kind of a step up from the bracket notation. So you have your data frame, you do .lock. For this specific function, you don't use parentheses, you use brackets, and then you put your list of rows, comma, your list of columns. So this is really nice because you can also select one or more columns or rows. You can select like any combination, and it will neatly and quickly select all of them for you, whatever you want. So looking at this one, I guess also another important note, it's always the list of rows first and then the list of columns. And this is, I think most of the time whenever you're like doing anything with rows and columns, it's usually going to be rows first and then columns. Like same thing with the shape function that we saw earlier, with lock. It's and anything else that uses rows and columns, it always lists out rows first and then columns. So, okay, yeah. So going into this first example on the left, so we have the name of our data frame, we have .lock, and then we can see the rows that we want to select. We want to select the 0 and 1 rows, and then we want to select the name column, which is what we see right below down here. And if you remember, we had the age column, so that is now not part of our result. So we essentially we only selected the name column. So we didn't select the age column, so that's not here anymore. Another way of doing this specific thing for this specific data frame, since we only had 2 rows, we could select 0 and 1, which were the 2 rows that we had, or another, I guess, not quicker, but quicker to type for you, is using the colon. So if you use the colon for either the row or the column, what that means is you're going to select all of the rows or all of the columns based on where you put it. So this colon represents all. So yeah, in this case, since we put it in the row space, the row section of the function, we're selecting all of the rows. And then here we are just selecting the name column. So we get the same result for this specific data frame. So kind of similar to the bracket notation based on how many brackets we were using, whether we put a list into the function or not. That changed whether our result was a data frame or if it was a series. So we have the same thing here actually. So if you put a list into the function, so if both the rows and the columns, they're in a list as we see here, the one is in between 2 brackets and the name is in between 2 brackets, then our result is going to be a data frame. And why? It doesn't matter what the result is, because after we do this and we select whatever columns and rows that we want, then we can use other data frame related functions on this result. Versus if we just have one list and one name. So over here, the 1 is now not enclosed in brackets, whereas the name is enclosed in brackets. So we have kind of one of each, a list, which is this, and the name. This is going to result in a series. So we can see that even though we get the same value, which is Jill, in both of these, the actual result and the type of result that we get is different. So, and then in this example, in both cases, the row and the column, we don't have a list at all. We just have the name of the row and the name of the column. So the result is just a single value. So it's what we get at that specific row and that specific column that we're looking at, what the data value is at that particular place, and that's the result. So this is just a value. So in this case, this is just like a string that has a string Jill, the string Jill. So yeah, based on how you, I guess essentially to kind of summarize everything that's on this slide. So what you put into the lock function, even though we have like the same data frame, the same function that we're using, and the same like the first like one row 1 and the name column, even though that's the similar part of each of these three examples. Putting brackets around each of them changes how the output is going to look like. And the output, based on the output, like you can do different things. Like it kind of goes back to the concept of data types. Based on what data type you have, that determines like what functions you can use later on. Any questions about this? Okay, doesn't look like any questions so far. Cool, let me move on. So the next thing is Ilock. So Ilock is very similar to lock, as you can probably tell by the name of it. Both have lock in it. Ilock instead, the I stands for integer. So this is integer location. So the main difference between lock and ilock is, or I guess similarities first. Both of them, ilock you can use to locate rows and columns as well, just like we did with lock. And the formatting and everything is very much the same with the whole brackets and like how you use the function and everything. The only thing is the difference, you use the position of the rows and the columns. So instead, so like the column, like previously with lock, we used like the name column or the age column in order to select like which specific column that we wanted. This wouldn't work with ilock because you can only input integer positions based on like what number column it is or what number row it is. Yeah, so I'll show an example of this in a bit, but that's the main difference. So like if we go back to or I guess like if you imagine the Jack and Jill data frame that we had, instead of saying like name or age, we would instead put like 0 and 1 as the column positions. So all of the inputs into ilock are going to be integer values. And then it's the same kind of formula, I guess. Like if you have a list and a list as the inputs, it's going to be a data frame. A list and a name is going to be a series output, and then a name and a name is going to be a value. So all of that's the same. The only difference is you're like getting the position of the rows and the columns. Cool. So filtering is the next thing I'll be talking about. So with filtering, you can, and this is also very commonly used, if you don't want to use part of your data frame, or if you want to only get certain things that you're interested in, filtering is a great way to do this as well. So we use the bracket notation for filtering. So this, we have our data frame, bracket, and then inside we're going to have a logical condition. So I think the best way is to just go down to the bottom of this slide where we see an example. So for example, here we have two conditions here. So we have df name, which represents the name column, and if that is equal to Jill. So that's what this is saying. So it's looking at df name, and this equal sign represents like comparison, like if this column is equal to Jill. So if any value within the name column is equal to Jill, then this is going to be true. And if it's not, it's going to be false. And we have a very similar thing here. So if the age column, it's equal to 18. So these are kind of like the formats of conditions that we can use. And if we put it into the data frame, so this whole thing that's within the parentheses, into the data frame, then we will get a new data frame that's now filtered by that condition. So you can put one condition if you want. You can also put multiple conditions. You can put as many conditions as you want. With one condition, you would just put this like df name equals Jill. You would just put that within the brackets. If you have multiple conditions, that's when you need to use parentheses like we see here. And the parentheses are kind of to separate the different conditions. So you would enclose each condition within parentheses, and then you can use what's called logic operators if you want to, based on like the different conditions, if you want both of them to be true, if you want just one of them to be true, like either or, if you want one of them to be true and like one of them to be false, you can use negation. There's a lot of different combinations that you can do with the different conditions. So in this one, we're looking for we want to select and filter out. So we get any rows where the name is equal to Jill, and then this condition is saying age is equal to 18, but we have this negation, so we don't want age to be equal to 18. So combining both of these conditions, we want name to be Jill and we don't want the age to be 18. So as a result, we get this row, which is Jill, because we want the name to be Jill and the age isn't 18. Okay, that is it for the slides. I definitely went through a lot, and hopefully if you have any confusions about what I just talked about, it will be cleared up right now when I move to REPL. Okay, hopefully you can see this screen. But basically, we're going to be talking about all of the different functions that I just discussed on the slides, but we're going to be using a slightly better data set. So we'll be using the baby names data frame. I will also send this specific REPL and the CSV file that I'm using for the baby names after this Zoom call. But yeah, I'll just be demonstrating everything we talked about. If you have any questions about any of the functions, please drop it in the chat. But yeah, over here on the left hand side of the screen, we can see I did import pandas as PD, that way I can use pandas. And then I uploaded so I'm using an external CSV. So I just basically uploaded it to REPL, and the name of it is babynames.csv. And then I'm reading that in. So I'm using the read_CSV function in order to use it now in REPL and to use pandas. So the name of this data frame, I called it baby names DF, just so it's very clear what data frame I'm working with and the fact that this is a data frame. I abbreviated it using DF. So I already ran this line of code, so to see that it works, I'm going to type in head. Hopefully REPL did not cancel out on me. Oh, okay, let me run this again. So when you use pandas in REPL, so I have the code here. I pressed run, which means it basically runs the script. I commented everything else out though, so it's only running these 2 lines. And then it does some package configuration stuff, basically, so you can use pandas in REPL. So let's just wait for this. This takes maybe like a minute. Okay, I think it should be good now. So just to check that everything's all imported, I'm going to try calling head. So this was way back in the beginning of the slides, but head, if you remember, that allows us to see the first 5 rows of our data frame. And perfect, okay, so we can see the first 5 rows. And why I love using head as like one of the first things to do whenever I read in a data file. So we had this data file. We so far don't know much about this data, but by using head, we can kind of get a sense of what it looks like. So over here, we see that we have 4 different columns. We have the year, we have the name, percent, and we have the sex. So what these all represent, so what this baby names data frame is, it has the top 100 or the top names, baby names for boys and girls for specific years. So here we see we have like one specific year. They're all, I think the data frame is completely ordered, which is why we only see 1880 as the year and boy as the sex. But if we wanted to see if the values differed or not, we could try running tail. So this gets the last 5 rows of the data frame. And yeah, so this kind of confirms our thing that the data frame is ordered. So we see now the year 2008, and we see some girl names. And then we also have this percent column, which represents like the popularity of the actual name. So yeah, so like I mentioned with head and tail, so the default value, so just by doing parentheses and not putting anything in it, the default for that is 5 rows, as we can see from both of these results. Let's say we wanted to get like, I don't know, if we wanted to get like 20 values or something, we could just put 20 within the parentheses, and then we would get like the first 20 values since we did head. And you could do the same thing for tail as well. Put any value in there, and you would get like the output of that many rows of that. So we've kind of seen like what our data frame looks like right now, like what the structure of it is. We can see that we have 4 columns and stuff, but maybe we want to check like how many rows we have just to see like the shape of our data frame. So in order to do that, we can use the shape function, which I talked about. So to do that, we just do our data frame dot shape, no parentheses needed here. And then this outputs a tuple, so the number of rows is first, and then the number of columns is the second value. So here we see we have 258,000 rows in our baby names, and then we have 4 columns. So yeah, so this is definitely a larger data set than our Jack and Jill play data set that was in the slides, which is kind of cool. So that is also useful to know. We definitely don't want to output the whole data frame right now, because otherwise we're going to just get rows and rows and we're going to have to keep scrolling through the data. So it's definitely a good thing that we used head, tail, in order to check out our data versus just outputting the whole thing. So another function I talked about was the size function. So this gets the number of data values that are in our data frame. So here we get how many zeros? So we got 1,032,000 different values, and this is just like the number of rows times the number of columns. So this is counting up like 1880 John, this percentage boy, and it's counting up every single one of the values in the whole data frame. So this tells us how many values we're working with. So kind of similar to shape, but a slightly different value. So let's say we wanted to get a list of what columns we're working with. Here it's pretty clear what columns we're working with because there's only 4 columns, but if, let's say, we had a larger data set that kind of like went off the screen, this would be a really useful function in order to see like what columns we're actually working with. So we can use .columns, and then we get a list of the columns. So year, name, percent, and sex, which is exactly what we expect. We can also I talked about the baby names, or I talked about the .values function. We could run that as well if we wanted to. I'm not going to run it right now because that's going to output a whole bunch of values. All right. Actually, I could. Just to show you. So we have values. Okay, so based on like where you're using, like what browser, if you're using like REPL or if you're using something else, this .values function will output a certain number of different values. So, okay, luckily REPL knows that .values is all of the different values. So here we don't see all of the different values. Instead, it gives us the first 3 and the last 3, and then it gives us this ... showing that there are more values that it's not showing. I have seen other cases where, like, not in REPL, but in other different consoles where you do .values, and then basically the whole screen is just rows of data. So yeah, based on how big your data set is. Okay, so let's move on. Or I guess any questions about what I've done so far? Okay. Cool. Let's move on in that case. So next we can try sorting different values. So we have baby names, and then we can do the sort values function. So if you remember the sort values function, we can put in 1 or more columns into the function, and then we can also say if we want it to be ordered in ascending order or descending order. So let's say we want to order, or we want to sort using the name. So essentially we want it to be in alphabetical order. And let's say we want ascending to be equal to true. So we want it to be in alphabetical order. So then we can see the output is, it starts with A, and then we again have these ... ellipses, which represents that it's not showing all of the data because it doesn't want to crash the system. But we have start with A, and then we have the names ending with C. So it is in alphabetical order at this point. Let's say we wanted to sort by multiple columns. So we want to maybe organize it by the year and the name. So we can do this using the same sort values function. So instead of just putting name over here, we can make a list. So we can also put year as well. So we have we have a list with the different columns that we want to sort by. So if we run this, so what this does is first it goes in order of the columns that are in this list. So first it looks at year and it sorts everything by year. So here we see 1880 is first, which is good because that's the lowest year, the oldest year. And then we have 2008 at the bottom, which is most recent. And then it looks at the name. And then within each of these years, so within the year 1880, it's going to sort everything there. And then, so yeah, we can kind of see the alphabetical order by name working as well. So yeah, that's sort values. In the slides I mentioned there was a parameter called in place, like that, in place. So in place, so let's say we just like ran this code here, which sorts the data frame by year and by name. So we ran it, we got the output. Let's look at the data frame. I'm just going to look at head. And we see that the head is different from this. So essentially in place, since we didn't put in place equals true, and we didn't set this output to be equal to a new variable, this result isn't saved. It's just outputted, which is why we get our original, the initial head output that we had in the beginning. If we did want to keep this output, there are two different things we could do. We could do in place equals true. So what that does is any changes that are made to this baby names df, like by sorting it, any changes that are made, it's going to just save it into that variable. So override whatever's in that and save this new output. Or if we didn't want to use in place, we could instead go here and then we could do baby names df, which sets this output to this variable. Or we could name it something else, like, oh, whoops. We could name it something else like baby names df sorted. So let's say I run that. So it's saving this sorted data frame output, into this new variable. And then now if I run head on this, we're going to see that it's the first few rows of the sorted data frame. So in place helps to save your output into the original variable, but another way you can do that is just by setting it to a variable. Cool. So let's going back to baby names. Oh, typo. baby names df. So let's say we want to rename our one of our columns. So we can use the rename function. And let's say we want to, instead of name, we want this to be first name, which by coincidence is actually the same example in the slides. But let's say we want this to be first name because we don't see any last names here. So we want to be a little more specific with what this column is talking about. So we can put the initial name of the column, which is name. That's what it currently is. And then colon, and then what we want the new name of the column to be. So in this case, maybe we'll say first name. And then, oh, I forgot. Remember syntax. So we have to make sure to put the columns, equals, and then these interesting bracket things. So columns is a specific parameter that is special to the rename function. So I guess what Python's doing, it looks, once it sees that you want to use the rename function, it looks at the specific parameter and then it's able to do things once it knows that you're using this parameter. So columns, equals, and then we have these bracket things. This is like a different data type. It's called a dictionary. I don't know if we talked about it, but it kind of like associates like this first value with the next value. So here, name is associated with first name as the column names. So if we run that, so here we see that our data frame, all the values are still the same, but the only thing that's changed is the first name is now our new column name for this. And kind of similar to that idea of like saving your result and like seeing what and like in place and everything I was talking about related to that before. So with this, we didn't save this result to another variable. We didn't use in place or anything. So if we were to just see this data frame again, we see that first name isn't there anymore, and that's because we didn't save the result. So if we wanted to save the result, we could do something like baby names df equals, and then this whole thing. And then if we look at baby names now, we see that first name is the column name, and that's permanent. Cool. So some of the other functions we talked about. So if you wanted to get the column data type, so what each column's data type is, we could do our data frame dot d types. So this shows like what each column, what the values in there, like what data type they are. So we have year, which is an int, which is kind of expected since we have a value, a year value, so that's an int. We have first name, which is a string, but remember that this gets outputted as an object with pandas, an object data type. We have percent, which is a float, and this makes sense because it is a numerical value, but it is like a decimal, so decimals are floats in Python. And then we have sex, which is an object because that's a string, whether it's a boy or a girl. So the next few things that I talked about in the slides are related to kind of like bracket notation and selecting, filtering, and things like that. So let's do that. Oh, let me check if there's any questions. Okay, no questions. If anyone has any questions, feel free, drop them in the chat. Cool. So let's say we wanted to just select a certain column from this data frame. So we can do baby names, DF, and then we can use our bracket notation in order to select a specific column. And selecting a specific column based on if we want the result to be a data frame or if we want it to be a series, we would put an extra set of brackets as like a list, for example. So let's say I just want to get a series. If I wanted to just get like, I don't know, if I wanted to just get like percent, then I could do that, and this just gets the percent column. So this has all of the rows just of the percent column, and this output is a series. And we could do this with any one of the columns, just using the same thing, except instead of percent, we would put the column name. So I talked about value count, so like the kind of the count or the values, like how many times each value occurs. So let's say that we wanted to like see how many names occurred per year. So let's do baby names DF, and let's do year. So we're getting the year column, this series. So this itself, so if we were to run this, actually this result is going to be a series, and then from there we can use value counts. So value counts can only be used on a series. So if we just run value counts, so this shows us that wherever, so in our data frame, wherever the year is 1919, there are 2,000 names. For like 1983, 2,000 names. So it seems like all of the different years here, they chose the top 2,000 names. If we wanted to sort this result, we can use this sort index, and this is because we're working with a series and we want to sort a series. This works very similar to the other sort values function, where it just sorts the year here on the left. So we see like all the way 1880 to 2008, all the different years, and with each year, the value of how many times a year appears in the data set is 2,000. So 2,000 for each. So it's a very even data set, it looks like. They just chose like the top 2,000 names per year for both boys and girls. So let's use value counts in a slightly different way. So let's say we wanted to see what the most popular names were in the data set. So we could get first name, and then we could run value counts on that. And out of the whole data set that we have, we see that Jesse occurs 258 times, which is the most. We see Leslie occurs 240, 247 times, and then so on. And we see that there are a few names, potentially even more because we have this ellipses. There are a few names that occur only once out of the whole data set. So we have Irby, JC, Elena, Gusty, Clyde, and all of those occur just once. And also a kind of cool thing, so this kind of gives us some information about the output. So we ran value counts on first name, and then we have this length. So this tells us the length of the output. So this is 6,782. So this represents like how many different rows are in this output. So for this like specific output, this also shows that this is how many unique names are in this data set, because each of these names will only appear once, because that's how value counts works. So out of this kind of huge data set that we saw, that was it was like 200,000 or something rows, there are around 6,000, 7,000 unique names in the data set. So kind of cool. We're just using some, we're just like doing kind of like one-liner codes, but we're already getting some like really interesting insights into our data, which is really cool. So now, kind of the last thing I talked about in the slides was like slicing, lock, iLock, filtering. So let me quickly go over that. I know I'm running over just a little bit, but yeah, this is some interesting stuff, and you'll definitely something that you can be using in your projects in order to gain further insights. So yeah, so slicing, let's say that, so I kind of went over this actually, but let me just to reiterate, let's say if I do first name, so this is going to result in just like we're selecting the first name column, getting all of the different rows. This result is going to be a series, but if we wanted the result to be a data frame, because maybe we want to run some nice data frame functions on it, we can have the column within a list. So it doesn't look too different here. Like we still have like the same values and everything, but the actual kind of like structure of it in Python is different. And we can kind of see like some differences, like with the series we have this like informational part at the bottom, whereas here we have this. So I talked about how a series was one-dimensional, which means that it does have a length, but there isn't any concept of like rows times columns. Whereas with the data frame, we do have that. So we can see that there's this many rows and like one column. So it's like a one column data frame. Cool. Let's so yeah, that's kind of like slicing with brackets. You could do that with like any column that you want. So now let's try using lock in order to select certain rows and columns. Sorry, okay, I think my REPL by accident refreshed on me. Okay, okay, I'm just running the first two lines again because the whole thing just refreshed. So let's give that a moment. Any questions, feel free to drop it in the chat. I'll also send out this the baby names file to you all. It's not super big. I think I should be able to send in Discord. I'll send that out afterwards along with all the code that I'm running. Okay, let me check that. It's imported. Okay, cool. Okay, cool. So, okay, we're talking about lock. So, let's say that we want to select certain rows and columns. So this is kind of like the general structure, and this general structure will make the output into a data frame. So maybe, I don't know, we have a lot of different rows and columns to choose from. So maybe let's get like the fourth and, or, okay, so okay, maybe I'll use stuff from these rows. That way you can see that it's actually working. So let's get maybe like 1 and 3, and then I'll do first name. So what this, did I make a typo? I probably did. Okay, well, what
name, not first name, because you didn't, because in the data set.
Oh, right. Oh, you're right. But yeah, okay, yeah. Okay, there we go. That's what should have happened. Yeah, okay. Original, I was still on the whole first name thing because I refreshed. Okay, yeah, thank you for that catch. But as you can see, this selected William and Charles, which we see are 1 and 3, the 1 and 3 rows, and then it just got the name of it. So that's kind of how you can use lock in order to select. If you wanted to get like maybe all of the different columns, you can just use this colon, which selects all of the like elements in it. So we're using it for columns, so this will get all of the different columns that we have for those specific rows 1 and 3. Yeah, and you could do the same thing with rows as well. For the sake of time, I will skip showing you that. But moving on to Ilock, let's say we wanted to use Ilock. So we also have this kind of similar structure as lock if we wanted to output a data frame. So let's try, so for columns, we only have 4 columns to work with, which means that the index or the values that we input into this column section can only be 0, 1, 2, or 3. So I will do 0 and 1, which are year and name, because we've been working with that a lot. And then let's see, row, let's do 45. Let's see what's in 45. We haven't seen that one. So this gets us row 45, the year, and the name. And we see that it's Michael. So that's, so yeah, the difference between lock and ilock, same structure and everything. It's just that you use integers, which represent the positions of your row and column, in ilock, versus lock, you could use like name. And then filtering, which is our last concept for today. For filtering, so we have let's say we have this series, what filtering uses is certain Boolean conditions. So what these conditions look like, so let's say we want the year to be greater than or equal to 2000. That's what this line is representing. Let's say we just run this. This is the actual condition. It's assigning each row to false or true based on if it is greater than or equal to 2000 or if it isn't. So what we then do is we put this condition into our data frame using the bracket notation. And what that's going to do, these true and falses, it's only going to get the rows that are true. So in this case, we can see, so our condition was greater than or equal to 2000. We can see that our data frame starts at 2000. And remember, the data frame's already ordered. So we start at 2000, and then we end at 2008. So, and we can also see that the number of rows went down, so it did in fact get filtered. So yeah, that was using one specific condition. If we wanted to do another condition, let's say we wanted to do another condition where we have...
Colony, I think we'll actually have to wrap it up since I know some people have told me they have to leave around now.
Okay, yeah, for sure.
Yeah. I know like Pandas is a lot to cover, and I feel like it's one of the most important things we are covering right now. So there's definitely a lot. I think you have everything on the slides as well though, right?
Yeah, everything's on the slides. I'll send out this code too. It's quite a large data set compared to like the examples on the slides and everything. So definitely there's a lot that you can do and like work with.
Yeah, okay. So if you guys do want to like test all the stuff she was gonna go over, you can go ahead and do that using like the code in the slides. I'm gonna keep this really short and quick, but so we've been looking at all the feedback you guys have been sending, so make sure you keep on sending that feedback. Hopefully we tried to make a few improvements today based on that, so hopefully that has helped. And make sure to include that in the attendance form, which I'm sending right now in the chat. So it's being sent, so make sure you fill that out before leaving. Along with that, if you have any questions about what we've covered or about the project or anything like that, make sure to stick them in the mentor help channel and tag us mentors. So you can go like @mentors, and that will notify all of us who are organizing this and will be able to help you. Along with that, for the project itself, we want to be the plan is to kind of have you guys kind of tinker with the data set using like pandas, numpy, and the different stuff you guys have learned, and then to give like a 1 to 2 minute like talk on basically what you've done with the data set. You don't have to create any slides or anything. We just want to hear what you have done and what you have gotten out of it, and that would be essentially on Friday. So you could just say like, oh, I used like this function to do this, and it helped me, identify this and about the data and learn something new. So those are the kind of things we just want to hear. So just make sure you have something like that ready and in mind as you are looking through the data. So that's all I have. You guys can feel free to leave. I will get yesterday's and Monday's videos up today, and I'll try and get today's video up tomorrow.